No? No questions at all? What? Nobody did it? He wasn't lying? Some people did. Yes. 737. Oh, look at there. Brett looks like somebody did it. 2 over 2x squared minus x minus 3. So what I want to do is factor that bottom, right? Because I want to know where does this equal 0. So negative 3 times 2x is negative 6x squared. So what multiplies to negative 6x squared but adds to negative 1x? Negative 3 and 2. That's exactly right. So I got 2x squared minus 3x. I always do my negative term first to make factoring a little easier. So then I take out an x here, and I take out a 1 here. So I have 2x minus 3 times x plus 1, and if I solve that, I get 3 halves and negative 1. So my first question is, are these asymptotes or are they wholes, and how do I know? Why? There's no canceling factor there. That's exactly right. So both of these are vertical asymptotes. So horizontal has to do with top heavy, bottom heavy, or same. Vertical asymptotes are when the denominator equals 0. What else? Y'all good? So, yes, because this one's bottom heavy. So the horizontal asymptote here would be y equals. When's the only time you get a slant or an oblique asymptote? Top heavy. That's exactly right. Other questions? You're good? Ready to move on? All right, well, we're going to finish this today. Y'all contain yourself, please. Yes, very. So is third block. Yeah. What does it say, Brad? Exactly. Maybe it's what? And what did it indicate? 2/3 of my classes are interactive and participate, and 1/3 doesn't. It's boring because you don't participate or say anything. Thank you, Brett. Thank you. I can always count on you to be honest Abe over there. Let's do some further analysis of rational functions, and then let's do some altogether from beginning to end. Yes. So we're hopefully going to be to the point today where you can graph a rational function by hand based on several different things, some of which we've talked about, others we haven't. So why didn't y'all tell me yesterday we had already done a whole lesson on vertical and horizontal asymptotes this year? We hadn't learned slants. I didn't realize we had done that. I didn't remember. So I don't know how, yeah, but anyway. Okay, well, now you should be really good at it. All right, so let's talk about what we know about rational functions. Remember, this is my f of x over g of x, two functions divided by each other. Instead of calling my horizontal asymptotes, I'm going to call them something else. I'm going to call them End behavior asymptotes. Why might I be calling them end behavior asymptotes? Thank you. I don't know at what point that it did cut off recording. All right, so y-intercepts plugging 0 in for x. Let's look at the very last thing that I want to talk about, and then we'll pull it all together. Nope. We did the difficult parts yesterday. This is like number 4 on the list of things we've talked about with rational. I just came over because this is going to take a little bit more room. So if to find the y-intercept, I plug in 0 for x, how do you think I find the x-intercept? Plug in 0 for y, right? So we know this happens but let's think about it because I'm talking about a rational function, right? Let's use that same one that I had. What was it? X minus 1, x plus 3, 2, over x plus 5. If that's my function and I want the x-intercept, so I know I want y to equal 0. So I want to know, when does this equal 0? How am I going to solve that? Okay, and then how do I solve? So when will x minus 1 times x plus 2 over x plus 5 equal 0? Each one what? So you want me to set this, this, and this equal to 0. I think you're thinking the right way and saying it the wrong way. How can you get 0 when you're in a fraction? If I'm dividing two things and they equal 0, we know when we're multiplying two things, one or both of them can be 0 to give me 0. But if I'm dividing two things, how do I get 0 when I divide two things? 0 has to be on the top. Why does it have to be on the top? If this is in the bottom, then it's undefined here, right? So it has to be in the top. So to do this, all I have to do is set the numerator equal to 0 and solve. No, because the denominator is going to tell me my vertical asymptotes. It's going to give me my undefined places. The numerator equal to 0. Now, again, this is only when the factors don't cancel. If the factors cancel, it's not a 0. And remember, whenever I'm talking about 0, I'm talking about x-intercept. I'm talking about crossing the x. You can. You absolutely can. Now, they will probably not be factored for you when you get them. We will have to factor them. But just for the sake of example here, and I'm going to run through one start to finish the way you'll do. All right, so here x equals 1 and x equals negative 2. Does that make sense? Would this one be top heavy, bottom heavy, or same? Top heavy, which means what? It's going to be a slant asymptote. The denominator only tells me about my vertical asymptotes or holes. Yeah. All right, y'all ready to run through one start to finish? All right, let's do it then. Are you prepared? Fixing to do an example. I want to pick a good one though. A good one. What? Brett, what? I want to do, well, we'll just run through everything, each one. How about the domain of this function? Can you find domain without actually graphing it? And if I tell you to analyze, this is what I'm talking about I want you to do for analysis, is go through these steps. So make sure you write this down so you'll know. Can you find the domain? Think back, Algebra 2, and even the beginning of this year. Yes. How can I find the domain? I need to find what x can't be, right? To find the domain, I find what x can't be. So is there anything here that x cannot be? Positive 8. Why can x not be positive 8? So my domain, not the domain. This also implies what? If the bottom equals 0 here, what do I have? We just talked about this one. Of what? Vertical what? It is undefined though, Vivian, you're right. Vertical asymptote at x equals 8. I am going to go ahead and factor this out before I jump to any other conclusions so that I can do a little further analysis here. How does the top factor? You should be able to factor that in your head. No leading coefficient. X minus 2, x plus 1 over x minus 8. Why did I need to do that? Holes, check for holes, make sure nothing cancels, right? All right. Before we get to range, let's look at x-intercepts. What is it? Y. You set the top to 0. Make sure nothing cancels, and it doesn't. X equals 2. X equals negative 1. What else have we talked about? We don't have one where we'll do everyone. Oh, you're talking about all the x's. Okay, so y-intercepts, let's do it. How do I do y-intercepts? Or the y-intercept? You put 0 in for x. So I'm finding f of 0. So this would be 0 minus 2 times 0 plus 1 over 0 minus 8. What is the y-intercept here? Anybody? Why can I not have 2 y-intercepts? It wouldn't be a function. It would fail the vertical line test. It would not show functionality if I had 2 on the y-axis. Everybody okay? We're doing good so far. What else have we talked about? Yes, Brett. I didn't mean it like that. When you put 0 in for, yes, not add, multiply. This is negative 2 times 1 over. What else have we talked about? Horizontal asymptotes? Yes, Miss McGee, we talked about that. Yes, guys, we sure did. We talked about horizontal asymptotes or in behavior models, right? So here, what situation am I in? I'm top heavy. What does top heavy tell me? I have no horizontal asymptotes, but I do have a slant asymptote. How do I find the slant asymptote? I have to do long division. So I want to go back to pre-factoring here, and I want to divide it out. So you guys try this on your own, and it's minus 8 into, what was it? Factor it. Tell me what you think the slant asymptote is there. You absolutely could. Good job. What'd you get? X plus 7. So I have a slant asymptote at y equals x plus 7. What else have we talked about? Let's think about a graph for a minute. Yes, so I'm going to graph it and kind of look at the graph to try to find the range. But I want to think about a couple of things first. Let me just put on here what I know. I know I have a vertical asymptote at 8. Do we all agree there? 2, 4, 6, 8. I know that I have a slant asymptote at y equals x plus 7. 6, 1 over 1 over 1. Probably should have gone by something a little more than what I did. That's okay. Do you agree so far with my graph? Yes, no, maybe so. I cross the x-axis at 2 and at -1. Anything else? Do I know anything else? I think that's it. Y-intercept, exactly right. And the domain is that x cannot be 8, right? Let's graph it and see what it looks like and see if I'm justified so far before I do anything else. So take out your calculator and let's graph. And it doesn't matter, you can graph it in factored form or you can graph it in the original form. But let's see if everything we've said so far holds true. Yes. Either way, you can do it either way, it doesn't matter. You're going to have to kind of really zoom out to see everything. They're like little swoop graphs. Does everything we said hold true? Yeah. What do you mean? Well, the reason that we found that was because we found the x-intercepts and the y-intercepts. So that's the only reason we had that. To find the other, we would literally be plugging in values of x to find what the pattern was there. You will. Eventually, we will. Right now, you'll have your calculator to help you. But by hand, what I'm looking for is that you can find everything we just went through. At least that much by hand, and then you can use your calculator to kind of guide you there. All right, so I see a vertical asymptote at 8, right? I see that slant asymptote coming in this way. I see the x and the y-intercepts at 2, at -1, and at 0.25. The only thing I need is to find the range now. And that I am going to have to use the graph. So I'm going to need to find these max and min points. And it goes up, it looks like, to about 0.652. Of course, you would go on your calculator and do second trace and then choose max or min, just the way we did before. And then 15.348. So what would my range look like here? Give me the range in interval notation. Anybody? Negative infinity to, and then it goes up to the y though. The y, I said it backwards, 0.3. And then from, that's right, up to. Does that make sense? And if I was sketching this, well, I'll go in and add them now that I know what they look like. So now that I know what these are doing, I'll go ahead and come in here. To find your range, yes. And this kind of dips down. This continues going up. I know you can't see it very well. Hugs this line. It's hard to draw it on here. But it's going to hug both. No, that's not going up that way, is it? Going. Sorry. There we go. So you would kind of sketch out the things you know. I'm really looking that you're finding all of this, all of these parts here, and then an accurate sketch. Yeah. So I just started at 7 and did a slope of 1. Other questions so far? Do one more example and I'll be done. Some of these can really start to look funky. You want to do another top heavy one that's got another slant asymptote? They're the hardest. So one more. Let's say f of x equals x minus 3. Oh, I'm going to open a can of worms with that one. Let me get one from your homework. This will be number, what did y'all stop on yesterday? 49. So let's do, might as well do a hard one. What is 56? So directions here to find the intercepts, analyze, and graph the function. Let's do intercepts first since that's what's asked for first. And this one's going to be a little bit harder. Let's do y-intercepts. Let's do y-intercepts first because they're the easiest. How do I find a y-intercept? I'm finding f of 0. Do we all agree? So I would have 2 times 0 cubed minus 2 times 0 squared minus 0 plus 5 over, what's my y-intercept? Are y'all confused or bored? Because the bottom is negative, so the fraction's just negative. Are y'all okay? X-intercept, or X-intercepts. I'm not sure how many it might have. How do I find those? I set the top to 0 and only the top. So my first question is, can I factor that? How in the world am I going to find PRZ? Gross. Or maybe, well, I guess we'll do PRZs. We could graph it and find the zeros. Yes. Let me graph it first and let me see if it has the real zeros, because otherwise I'm going to be in a situation of breaking it down into linear factorization where I might have to do the imaginary. You see what I'm saying? So let me graph it first and let me make sure, and then I'll show you the PRCs. Yes, you may. I'm going to put it in exactly the way it was given to me. So 2x cubed. Calculus had a question on their test today where they had to solve and could use their calculator. And most of them did not remember that if something equals 0, you can just find where it crosses the x-axis and those are the solutions. So I hope you guys remember. Did you remember? Oh, just the top, just the top. Still gonna get the same thing, but just the top. Oh, look, I only have what? 1. And it's not a nice whole number, so I probably would not want to PRZ this one. Right? You would, if I gave you one that was not factorable that way, you would definitely have your calculator to find the 0. So there's just one, so you would just say this happens when x equals negative 1.18. Yeah. But that tells me a couple of things, because that's going to help me with my vertical asymptotes. That's going to help me with my holes. That's going to help me with all of that good stuff. Because I know it's not factorable, I know I'm definitely not going to have an x minus 2 factor up top, right? Which means it's not going to cancel. So as far as vertical asymptotes go, what do I have? X equals 2. So I want to look where x minus 2 equals 0, so I know that x equals 2 is a vertical asymptote. Everybody still okay? Okay. How about horizontal asymptotes? None. Why? It's top heavy, it's a slant. So I do need to talk about the slant. Now, yes, I can do this one synthetically since I've got a linear factor on the bottom there, that x minus 2. So, if you want to do long division, you can. We'll do it both ways so you see. Bring down the 2. And I have 4, 2, 4, 3, 6. This doesn't matter, right? Because that's my remainder. So where is my slant asymptote? Gross, right? That means whatever's going on in this function, I have an asymptote that is a parabola. That's interesting, isn't it? Oh, there was a picture in here somewhere for you. All right. What else do I know? Is that it? Domain. What's the domain? What can't x be? 2. So what's the domain? Okay. How do I say anything but 2? Negative infinity. That's right. That's exactly right. Yep. X can't be 2. Bottom can't be 0. Everybody okay? Essentially, we've really only added in here today the x and y intercepts. So we're going to use our calculator to help us on this one, and I want you to see it, and then we'll sketch a graph. We won't be as precise. So let me just show you graphically what it looks like. Now I am going to come in and divide this by x minus 2. My biggest thing with this one is I want you to see that parabola that's bounding it. I really want to be able to draw on this. But this parabola, can you see my cursor as I trace? Can you see the kind of outline of the parabola here? It's bounding this side, and it's coming around, and it's bounding this side. Does that make sense to you? Can you see it, how it's bounding? So that's what a parabolic asymptote looks like. Everybody okay? I'm not going to go too deep into graphing rationals because I like to just stick on what you need for calculus because this is pre-calculus. So what you'll need to be able to do by hand and be able to look at, and 99% of the time, if you've got an equation like this, you do have your calculator to rely on for something like this. So I think I'll stop there and leave you to some analysis for homework, and then we can move on. So if there were a quiz anytime soon, we're looking at focusing mainly on asymptotes, intercepts, and graphs. Okay? These start looking funky. Okay, so I understand it, so don't think that any of them are, you got something wrong. All right, let me give you your homework.